Today let us start with lesson motion in a plane. First, vectors. Vectors should have magnitude, direction and vector laws of addition. Now types of vectors. There are two types, polar vector, axial vectors. Here you can see polar vectors. Today in this chapter we will discuss only polar vectors which have tail and head as shown in the figure like this. Then now examples. First in polar vectors, the congenital vectors, coinitial vectors, that is both tails are together and heads are separated, that means they are started together. Then coterminous vectors, they ended together like this. Then coplanar, here all the polar vectors are in the same line, in a same plane, so they call us coplanar vectors. Then here you can see unit vector represented by a cap. Here a cap equal to a by magnitude of a. So we can say a cap equal to a by magnitude of a. Now notation used in directions. Here let us take a plane, three-dimensional plane. Here y-axis, here x-axis and here z-axis. So we'll call x-axis as I cap, y-axis as j cap, then z-axis as k cap. Here you can see x equal to I cap, y equal to j cap and z equal to k cap. Now here equality of vectors. Here you can see if you say a equal to b, the both should be in the same direction, in same length, then only we can say if a equal to b. Let us take here the free vectors which are parallel to each other. They are also equal to each other because they have same length and same shape and same in direction, so they are called as equal vectors. Now here let us see the discussion of position vectors and displacement vectors. Here you can see the graph is shown. Here y-axis and x-axis are drawn and two lines are taken which are coinitial vector. So we can say coinitial vectors are rising from this point of origin, and the distance between these two coinitial vectors is represented as s. And for now let us assume that it is a circle like this. Then this is the radius and it is also radius. Now if we join, we'll get arc length, right? So the arc length is known as displacement, but if point 1 is going like this to point 2, then it is distance. So distance equal to, so displacement equal to r2 minus r1, where distance is always equal to displacement or greater than displacement, but never less than displacement or equal to 0. Now here let us discuss about various operation on vectors. First, addition, then subtraction, multiplication and product of vectors. Note, division by a vector is not defined because vector cannot be denominator. Now let us discuss about addition and subtraction of vector. Two types of methods are there in addition of and subtraction of vector, that is geometrical method, and second one is analytic or numerical method. First let us discuss about the first method known as geometrical method of addition. Here you can see the coinitial vector on two lines, that is b and a. If they are asked to find a plus b, then how will we find? If vector is shifted parallel to itself, then the vector remains unchanged. Now for example, let us take this v vector and shift it parallel to itself, then we'll get like this. A vector is as is and b is shifted to parallel to itself, we'll get. And if we join these both two, now we'll get Pythagoras. Using Pythagoras theorem we can find, or if we draw this triangle, so using Pythagoras law we'll get the addition of both a plus b. Now here convention for denoting angle between two vectors. Here you can see the vector a and vector b present. So we should not take the angle here. The smallest angle will be accurate angle, because as we can see here, this is the actual diagram. The angle between them is theta here, but we shifted this b to here parallel to itself, so it became like this. It becomes like this, but the actual angle is this. So we have to we should not take the biggest angle here. We have to take the small angle, that is this, which is equal to the theta which is formed here to the original vectors. So for this diagram, let us find a minus b. A minus b equal to a plus minus b. Here you can see like this. Now let us move on to the properties of vector addition. It follows the commutative law, that is a plus b equal to b plus a. A plus b plus c equal to a plus b plus c. It is known as associative law, which follows the vector addition follows associative law. Now properties of subtraction. Here a minus b is not equal to b minus a, and angle between a minus b and b minus a is 180 degrees. Now laws of vector addition and subtraction. Here you can see first law is known as the parallelogram law. Here you can see a parallelogram. If you have two cognitial vectors, that is a and b, as the adjacent sides of parallelogram, then the diagonal passing through their tails is a plus b and other is a minus b, as you can see here. These two are the vectors which I have given. If they are demanding to find the a plus b and a minus b, then the passing diagonal, one diagonal is a plus b and other diagonal is a minus b. Now let us move on to the next page. This is known as second law of addition, vector addition, known as triangle law of vector addition. Here you can see it is also known as it is known as triangle law of vector addition. Here you can see the triangle. If a and b and given, then you have to draw a line so that we will get a plus b using Pythagoras theorem. Now let us move on to polygonal law of vector addition. Here you can see a, b, c, d and e are the vectors, where r is the resultant. So resultant vector can be found like a plus b plus c plus d plus e. Now component of vector. Here you can see the ay equal to x. Here cos theta equal to base by hypotenuse. So we can write like x by a, x equal to a cos theta, and sin theta equal to opposite by hypotenuse. So here we can write ay by a. So ay equal to a sin theta. Here you can see the triangle. We will get a sin theta, a cos theta and hypotenuse. Now let us move on to the next page. Now let us discuss about analytical or numerical method of vector addition or subtraction. Here given a, in the figure you can see given a, b and theta. Now find vector r. Here a plus b and phi angle phi. Now let us find the vector r. Here as you can see in the diagram, r equal to under root a plus b cos theta square plus b sin theta square, r equal to a plus b square plus 2ab cos theta. A plus b equal to under magnitude gives rise to under root a square plus b square plus 2ab cos theta. Now a minus b equal to a square plus under root a square plus b square plus 2ab cos theta 180 minus theta. So finally we'll get a minus b equal to under root a square plus b square minus 2ab cos theta. So now let us discuss about the projectile motion, which is also known as oblique projectile. Here you can see projectile. The air here is the initial point. If the body is thrown in the motion like this, it is known as projectile. Here you can see the notations which are used. Angle between these is theta. The u is initial speed, v is final speed, and the theta angle between these two is same as here and here, and the maximum height is h max, and the range between these two is r range. T equal to time of flight. Now given initial speed and theta is initial angle with horizontal, so uy equal to u sin theta and ay equal to minus g, because we took upside as positive. Then here ux equal to u cos theta and ax equal to 0, and here u cos theta is constant. Expression for time of flight or t equal to 2t. T equal to time to reach upside using equation uy equal to uy plus ay t. So substitute the values. We know uy equal to 0 and u sin theta equal to u sin theta plus minus g into t. So 0 equal to u sin theta minus gt. T equal to u sin theta by g. So t equal to 2t. So t equal to 2 into u sin theta by g. Vector method division of time of flight. Derivation of time of flight. Here vertical displacement sy. So sy equal to 0 in entire motion. Use s equal to ut plus half at square. Here 0 equal to u sin theta t plus half into minus g into t square. Then 0 equal to u sin theta into t minus gt square. Therefore t equal to 0, and other is t equal to 2u sin theta by g. Now expression for maximum height or h max. Use v square equal to u square plus 2as. Vy square equal to uy square plus 2ays. 0 square equal to u sin theta square plus 2 minus g into h max. Now here u sin theta square plus 2 into minus g h max. So finally we'll get h max equal to u sin theta square by 2g. Now let us derive the expression for horizontal range denoted by r. Now use formula s equal to ut plus half at square. Sx equal to uxt plus half into axt square. R equal to u cos theta into t plus half into 0 into t square. So finally get the answer as r equal to u cos theta into t. So t, we know that t is 2u sin theta by g, so we'll substitute here. Then we'll get r equal to u cos theta into 2u sin theta by g. Then r equal to u square sin theta square into cos theta by g, or we can write as r equal to u square sin 2 theta by g. As we know, sin 2 theta equal to 2 sin theta into cos theta. Now let us know about horizontal range. For again the u, for given u, the range r is maximum, and then when theta equal to 45 called r max and h max is 1 by 4th of R max or R max by 4 when theta equal to 45. So theta equal to 45 degrees equal to H max equal to R max by 4. Now proof here, R max equal to U square sin 90 by G equal to U square by G. H max equal to U square sin theta sin square theta by 2G. So here equal to U square sin square 45 by 2G equal to U square 1 by V2 whole square by 2G equal to U square by 4G. So here we can see the H max equal to R max by 4 or 1 by 4th of R max. At theta equal to 90 minus theta for given U, the horizontal range R is same. Now let us discuss one question here. Given that there are two angles of throw for which the range R is same, but T is there two cases at T1 and T2. Now relate T1 and T2 with R. Here you can see the diagram as per question. Then R equal to, we know, U square sin 2 theta by G, or R equal to U square sin theta cos theta by G. So T1 equal to 2U sin theta by G, T2 equal to 2U sin 90 minus theta by G equal to 2U cos theta. So T1 into T2 equal to 4U square sin theta into cos theta by G square equal to 2R by G. Finally, they may be T1, T2 may be equal to or proportional to R. Now let us discuss about the equation of trajectory. Let the projectile be at the point P xy. After time t, uy equal to u sin theta, ay equal to minus j, and ux equal to u cos theta, x equal to 0. Here use the formula s equal to ut plus half at square for x direction, and for y direction here you can see for x direction minus x equal to u cos theta into t, since ax equal to 0. Then here y equal to u sin theta into t plus half minus gt square. That is second equation. Now here the elimination will occur. Then y equal to x sin theta minus half into gx square by u square cos square theta. Now angle made by velocity of projectile with horizontal after time t is tan phi using theta minus gt by u cos theta. Now horizontal projectile. Here you can see given u, h, g and derive the expression for the time flight t. Here we will use the formula sg equal to ugt plus half at square. Here s is also known as plus h horizontal range h max h equal to 0 into t plus half into gt square. H equal to half gt square or j equal to t equal to under root 2h by g. Now note t is independent of u or initial speed. Now let us discuss about derivation of the expression for the horizontal range. Use formula s equal to ut plus half at square, r equal to ut plus half into 0 into t square. Therefore r equal to ut or t equal to r by u. Since t equal to under root 2h by g, r equal to u into under root 2h by g, where r is proportional to u. Circular motion. Now uniform circular motion, basic terminology. Uniform means speed is constant, the magnitude of velocity is constant, direction of velocity is changing, that is therefore velocity is variable. Here angular displacement theta is unit is radian, whereas angular speed or angular velocity is omega equal to theta radian by t, theta by t or radian by second, also called as angular frequency or circular equality. Now time period t, the time taken to make one complete round is called as time period t. Frequency or nature of frequency or f or v The number of rotations in 1 second is known as frequency. Frequency equal to 1 by time period. The unit is hertz or CPS. Now relationship between W and T. Consider a complete circle. W equal to theta by T equal to 2 pi by T, where W equal to 2 pi by T. Since 1 by T equal to F, so we can substitute that. So we'll get W equal to 2 pi F. Now meaning of RPM. RPM equal to revolution per minute. The practical unit of W or F equal to 1 RPM equal to 1 revolution by minute equal to 2 pi by 60 seconds or pi by 30 seconds. Now W equal to theta by T equal to 2 pi by T equal to 2 pi F. Example. Now here you can see the question. What is the ratio of angular speed of minute hand and hour hand of a standard watch? Now use W equal to 2 pi by 1. Here W minute equal to 2 pi by 1 hour and W hour equal to 2 pi by 12 hour. Then W minute by W hour equal to 12:1 or 12 by 1. Relationship between the V and W. V equal to linear speed meter per second, W equal to angular speed radian per second. Here SC by T equal to R by T, so V equal to R omega W. So S equal to arc length M, V equal to S by T, that is distance by time. Therefore theta equal to arc length by radius S by R. Now here you can see one numerical. Now let us move on to the centripetal acceleration. Here condition for circular motion, it should have velocity and always perpendicular to acceleration, then the centripetal acceleration occurs. Here you can see. You can derive S equal to V square by R, W R square by R. So S equal to W square by R, S equal to W into W by R into W V. S equal to V square by R equal to W square. R equal to W V. Here non-uniform circular motion, that means implies that V or W is no more constant. Here triangular arc A equal to dV by dt. Here centripetal arc AC equal to V square by R. The total acceleration A equal to under root AC square plus AT square meter per second square. V by T equal to WR by T. AT equal to alpha R. Unit radian by second square, where alpha equal to angular acceleration. Now relate to velocity in one dimension. Here you can see VAB equal to VA minus VB. VAB equal to velocity of A with respect to B. VA equal to with respect to ground. VB equal to velocity of B with respect to ground. Then boat river problem. Here you can see example of boat river problem. So here we have completed the lesson motion in a plane. Thank you.